Hello dear students, in the last video we have studied about the Euler's method to solve the first order ordinary differential equation. In this video we will learn about modified Euler's method. Since Euler's method is a simple technique for numerical solution, so we can improve the situation or the solution with Euler's modified method. So let us see what is Euler's modified method. So consider the differential equation dy by dx is equal to function of x and y with the initial condition y of x0 is equal to y0. Now this equation can be written as dy is equal to f of x comma y into dx. Now integrating on both sides, integrating this equation on both sides, here we get integration y0 to y1 dy equal to integration x0 to x1 f of x comma y dx. Suppose this is equation 1, then we can use the trapezoidal rule, and using this trapezoidal rule we can obtain the equation as integration x0 to x1 f of x comma y dx is equal to h by 2 into f of x0 y0 plus f of x1 y1. So what is the trapezoidal rule? Trapezoidal rule is integration f of x dx x0 to x1 is equal to h by 2 into y0 plus yn, that means the sum of extreme terms plus 2 times the sum of intermediate terms. So using this formula, here we get this equation. Now using equation 1, we get, what is our equation 1? Integration dy y0 to y1 is equal to, now we can put this step using instead of this. So here we get integration dy y0 to y1 h by 2 into f of x0 y0 plus f of x1 comma y1. Now while integrating this, we will get and putting the limits, we get y1 minus y0 is equal to h by 2 into f of x0 y0 plus f of x1 y1. Now shifting y0 to right hand side, we get y1 is equal to y0 plus h by 2 into f of x0 y0 plus f of x1 y1. Now this is our first iteration, so we write y1 1. So in the first iteration we get y0 plus h by 2 into f of x0 y0 plus f of x1 y1 0. That means initially the value of y1, where y1 0 is y0 plus h into f of x0 y0. This is obtained by Euler's method. And similarly for the second iteration or the next iteration, we get the formula y12 is equal to y0 plus h by 2 into f of x0 y0 plus f of x1 y1 1. This is the value of y1 in first iteration. Similarly y13 and y1 n plus 1. So y1 n plus 1, that means n plus 1th iteration, value of y1 can be calculated using this formula y0 plus h by 2 into f of x0 y0 plus f of x1 into x1 comma y1 n. So this is called Euler's modified formula. So let us take one example. Given dy by dx is equal to x plus y with initial condition y of 0 is equal to 1, and we have to find y of 0.05 by Euler's modified method, and we have to take h is equal to 0.05. So here we have given the function f of x comma y is equal to x plus y, and given y of 0 is equal to 1. That means x0 is equal to 0 and y0 is 1. Also, we have given h is equal to 0.05. So our first step is to find the initial approximation by Euler's method. So our Euler's formula is y1 is equal to y0 plus h into f of x0, y0. Now our function is x plus y. So our initial approximation is y10 equal to, now y0 is 1, so 1 plus h is 0.05 into, now the function is x plus y, so f of x0, y0 is equal to x0 plus y0. So x0 is 0, y0 is 1. So here we get the initial approximation of y1, that is equal to 1.05. Now, as we know that Euler's modified method is iterative method, so we will take a number of iterations to the desired value. So now by Euler's modified method, y1 n plus 1. So n plus 1 value can be determined by this formula, y0 plus h by 2 into f of x0, y0 plus f of x1, y1 n. Now here putting the values of y0 is 1, h is 0.05, we get this value 1 plus 0.025 into function of x0, y0, that is 0 plus 1 into function plus function of x1, y1 n. Now we don't know the value of y1 n. We are going to find that value. So our first iteration, now as we have y10, we are going to find y1, 1. That means first iteration. So put n is equal to 0 in equation 1. Now this is our equation 1. So by putting n is equal to 0 in equation 1, we get y1, 1 is equal to 1 plus 0.025 plus, into 1.05. 1.05 plus y1, 0. So here we get 1.05. Now this 1.05 is 1 plus 0.05 plus y1 n. So here we get 1 plus 0.025 into 1.05 plus y10 is 1.05. And this is the value of y11, that is equal to 1.0525. This is the value of y1 after first iteration. Now in second iteration, put n is equal to 1 in equation 1. So when putting n is equal to 1, we get here y1, 2. That means this is our second iteration. So in second iteration, y1, 2 is equal to 1 plus 0.025 into 1.05 plus y1, 1. Now in the previous iteration, we got the value of y1, 1, that is 1.0525. And after calculating this, we get y1, 2 is equal to 1.05256. Now in first iteration, we got y1 is equal to this. So comparing so it is correct up to 4 decimal places. Again, we take third iteration. So for third iteration, we put n is equal to 2 in equation 1. So we get y1, 3. y1, 3. So in y1, 3, we put here y1, 2 in equation 2. So we get 1 plus 0.025 into 1.05 plus 1.05256. And simplifying, here we get y1, 3 is equal to 1.05256. Now these values are correct up to 5 decimal places. These values are correct up to 5 decimal places, y1, 2 and y1, 3. So here our final value of y1 is 1.05256. That is y of 0.05 is 1.05256. So we take the iterations till we get the desired value. That means for some decimal places, the value should be correct. So in this way, we can find the values using Euler's modified formula. Thank you.